Welcome to Campaway. I'm Chris. You might be wondering why I'm standing in front of a pool with a water gun in a video titled Electricity. It's because water can be used to help visualize electricity. Unless you're an avid follower of Frankenstein or Tesla, you probably don't often see the visual aspects of electricity, just the results. I'll use my water gun and other items found around the campground to help you visualize the invisible world of electricity. Now, when you visit a campground, you'll often hear the terms like volts, amps, watts, AC, DC, 120, 240 thrown around, and it can all get confusing if no one's ever taken the time to help you visualize them. We'll start with AC and DC. They're more than just a great rock and roll band. They're the style of electricity that's delivered. AC and DC stand for alternating current, used by your plug-in devices, and direct current, used by your battery-powered devices. DC electricity provided by your batteries can be visualized by a river system. A full mountain reservoir empties its contents in one direction from positive to negative downhill, where it can be used by a water wheel to do work on its way to the ocean. Once emptied, the reservoir must be refilled to do more work. Think of that as evaporation. Rain and snow melt is recharging your battery. AC electricity from the campground's power system can be thought of as the back and forth motion of a rocking chair or a slider or rocker that we have on some of our ultra patio sites. Volts are a measure of potential energy. In my water gun, it's how many pumps do I charge the tank. In Water Wars, it's how far back do I pull the water balloon launcher. How much higher is that mountain lake than the ocean? Or the difference between the high and low tides. Your RV has a 12-volt battery system and a 120-volt plug-in system. Now, amps are used to measure the kinetic energy. How far back do I pull the trigger? What's the size of the water balloon that I launch? How fast does that river or tide flow? The fuses and circuit breakers in your RV are rated by amps. Too much electricity flow and it'll pop a breaker or blow a fuse. Think of it as a speeding ticket. Now, volts and amps are independent. The distance I pull this bucket back has no bearing on the size of the balloon. And the size of the balloon doesn't really have any bearing on how far I pull this back. But if I want to combine them, volts times amps, that's watts. That's the work, the power that I can get out of it. So I can have a small amperage and a small voltage, or I can have a small amperage and a large voltage. Now, numbers, you've heard 12, 20, 30, 50, 120, and 240. Well, a well-meaning handyman or a reservation clerk may have thrown these seemingly random numbers at you, expecting you to know what he or she was talking about. But they're all measures of the volts and amps associated with your RV's electrical system. Now, 12 is the measure of voltage of your battery-powered DC system. Your RV uses your 12-volt battery system to power its ceiling lights, its water pump and vent fans, and some other appliances. Check your owner's manual. Now, 20, 30, and 50, those numbers are used as the maximum amperage electrical connection that a campground offers. A 20 amp plug is what your blender or your hairdryer uses, and these have 2 or 3 prongs. A 30 amp plug is the circular 3-prong plug that small to medium sized RVs use to power themselves. And a 50 amp plug is the 4-prong plug that the larger RV uses to connect to the campground's electrical system. And 240 and 120 are the standard voltage measurements of the campground's alternating current system. The 20 and 30 amp systems, the 20 and 30 amp plugs, use 120 volts, just like your house. Now, the 50 amp RV systems use a 240 volt systems, which is essentially 2 120 volt systems side by side. So people who work with electrical equipment can use these equations where they multiply the volts times the amps to get the watts. Avid RVers also use this equation to calculate their energy uses to avoid overtaxing their system. Now, a guest plugged into a 30 amp outlet might have to choose between turning off their coffee maker or air conditioner so someone can use the hairdryer or warm up the breakfast burrito in the microwave to avoid popping that 30 amp breaker. Using the volts times amps equations, we can see that the 30 amp 120 volt system, 30 times 120, can use up to 3,600 watts, whereas the 50 amp 240 volt system can use 12,000 watts of power. That's more than 3 times as much. But all RVers need to monitor their energy usage. We're used to our house system that's 2 to 10 times more powerful than our campers. Circuit breakers are designed for 80% usage or less to adapt for spikes, such as when you first turn on a vacuum cleaner, an air conditioner, or some other appliance. That means you should probably use propane to run your water heater or refrigerator on a hot day when the air conditioner never stops, to avoid overheating or even melting the electrical wires or plugs or breakers. Welcome to Campground. I'm Chris. They're deciding to do some weed whacking and tree pruning right now in the middle of the video. Yeah. Well, I hit the target. Product placement. Oh, shoot. I'm an idiot. Tell me something I don't know. Squirt, squirt, squirt. Alright. Really? Right when I get to that page in the script, that's when the wind blows and flips it upside down. Perfect. High voltage! Very low amps. Alright, that's the end of that.